So in chapter 9, we're going to start working with trigonometry. And first we're going to start with trigonometry for right triangles. Those are special cases. They're simpler, a little easier to work with. And we're going to find be able to calculate sine, cosine, and tangent for specific angles, as well as cosecant, which is the inverse of sine, secant, which is the inverse of cosine, and cotangent, which is the inverse of tangent. So if you explore your calculator, you'll find that you don't have a cosecant, secant, or cotangent key. They expect you to find sine and then find its inverse by using, depending on what calculator you have an inverse key or an x to the negative 1 power key. They're the same thing. It just depends on how new your calculator is in terms of how they notate it on the keypad. So the type of problem we might use this in is a case where we wanted to find the distance between two locations where it was impractical to measure using other means. And by being able to use surveying equipment to measure this angle and knowing this distance, we can calculate the distance here between these 2 points without actually having to travel through these mountains to make that happen. Okay, but first let's go ahead and look at what right angle trigonometry is all about. We're now looking for unknown angles in some cases. So when we have an unknown angle, we're going to talk about theta. So that's normally the variable we use for an unknown angle is theta, just like we use x. And when you start talking about how you calculate sine or cosine or tangent, you're normally using the sides of the triangles in order to do that. So the side opposite is just that. It's directly opposite theta, and the side adjacent is next to it. But you can see that with the same triangle, if I now worked with this other angle and it became a different variable, a theta prime, then you see that what was the adjacent side will become the opposite side, and what was the opposite side will become the adjacent side. So that's informative about, the trig functions of complementary angles, but what's most important is that you stay very clear when you're determining opposite and adjacent which angle you're talking about, because that becomes important. So when we want to calculate sine, it's the side opposite divided by the hypotenuse. Cosine is the side adjacent divided by the hypotenuse. And tangent is the side opposite divided by the side adjacent. And then cosecant, secant, and cotangent are the inverses of these, so you just flip the triangle. And what people often use to remember is a thing called SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent, so SOHCAHTOA. Okay, if that helps you remember and keep all this straight. And how we'd use that to find parts of a triangle. If I want to find the trig functions here, I want to find sine, cosine, tangent, cosecant, secant, and cotangent. If I want to find those, I'm going to need to find some parts. Now if you look over here, 3 is the side opposite. So I know that that's going to be over the hypotenuse here, and it's going to be over the side adjacent here. And then the reverse here and here. This is going to be the side adjacent, so that's going to be in the numerator here, and then in the denominator here, and it's going to be in the denominator of tangent and in the numerator of cotangent. So the parts I have missing are all the hypotenuse parts because the problem didn't supply that. So if I go ahead and find the hypotenuse, I'm going to use the Pythagorean theorem. I know that 3 squared plus 8 squared is equal to the hypotenuse squared. So that'd be 9 plus 64 would be 73, would be c squared, which means then that this side is the square root of 73. So this is going to be 3 over root 73. This is going to be 8 over root 73. This is going to be root 73 over 3, and this is going to be root 73 over 8. Sorry, I got this a little cramped up. But one thing we should remember from last semester is I have to simplify these. I can't have radicals in the denominator of a fraction, so this becomes 3 root 73 over 73, and this becomes 8 root 73 over 73. Okay, when I rationalize the denominator. So they might show me a triangle like this with parts, and they might tell me this information. They've given me the cosine. That means that 5 is the side adjacent, and 8 is the hypotenuse. So that means that I know that 8 squared was equal to 5 squared plus my unknown side squared. So 64 minus 25 would be b squared. So that's going to be 39 is equal to b squared. So if I go through now and I want to do sine is going to be root 39 over my hypotenuse, which was 8. Cosine we already have. Cosine is 5/8. And then tangent is going to be the side opposite, right, root 39, over the side adjacent, which was 5. Then if I want to invert these guys, cosecant would be 8 over root 39. When I rationalize that, that's going to be 8 root 39 over 39. Secant will be 8 over 5. And then cotangent would be 5 over root 39, but I have to rationalize that denominator as well, so it's 5 root 39 over 39. Okay, so it's pretty straightforward. It's not super difficult. Let's just do one more example where they gave me secant. Since they gave me secant, that means that I know that cosine was 5/12. Okay, and then that means that my hypotenuse is 12. My side adjacent is 5. Right, so this is side adjacent and hypotenuse. So I know that 144, which is 12 squared, is equal to 5 squared, which is 25, plus my side opposite squared. So this is going to be b squared is 119, so b will be equal to radical 119. So if I want to find sine, it's radical 119 over the hypotenuse, which is 12. Cosine we already knew, it's 5/12. Tangent is going to be rad 119 over 5. Cosecant will be the inverse of this, and I have to rationalize the denominator. So instead of 12 over radical 119, it'll be 12 times radical 119 over 119. Secant will be the inverse of this. It was what was supplied, 12/5. And then cotangent is the inverse of this. Again, I need to rationalize the denominator, so it's going to be 5 rad 119 over 119. Okay, if you don't remember how to rationalize denominators, you should talk to me or go back to information from chapter 1. That's where we learned how to do that. So go ahead and do some practice. Do problems 3, 6, 8, 9, and 12. And then take a look at the next video. When we're working with standard angles, and standard angles are multiples of 30 and multiples of 45, there's a predictable pattern to the values for sine, cosine, and tangent, and of course then also the same for cosecant, secant, and cotangent. And later we're going to find out how to find these from the unit circle, but for right now, I just want you to notice that when we have complementary angles, for instance 30 and 60, you'll notice that the sine of 30 is the cosine of 60, and that's because of the way the side opposite and the side adjacent switch places. Okay, and you'll notice then also that the tangents are inverses of each other. So equally, you'll find that the sine of 60 is the cosine of 30. For 45 degrees, the side adjacent and the side opposite are the same value, so these are always equal, and therefore tangent will be 1. Okay, so it's useful to have this table. You don't have to use your calculator when you already know what these are. Sometimes it's easier to work with them that way. That's part of why it's here, is to let you free up from using the tool. That means the calculator. So if I take a look at this, I know that the sine of 30 degrees would be equal to opposite over hypotenuse, so that would be x over y. Okay, so that may screw me up a little bit in terms of my ratios, so maybe that's not the first thing I would want to find out. But if you look at the cosine of 30 degrees, that would be 12 over y. Again, this is the hypotenuse, this is the side opposite, and this is the side adjacent. So now I could find cosine of 30, and then I would be able to find y. Equally, I could do tangent of 30 degrees is equal to x over 12. Okay, so I could do either one of these. This one will allow me to find y, this one will allow me to find x, and that way I can find these unknown parts of my triangle. So if I go ahead and go back to my table, pardon me, if I go back to my table, I can pull up the values for cosine and tangent of 30 degrees. So if I look at cosine and tangent of 30 degrees, cosine of 30 degrees is root 3 over 2. So cosine of 30 degrees is root 3 over 2 is equal to 12 divided by y. So if we wanted to continue to simplify this, I'm going to go ahead and move this down. If I continue to simplify this, I know that root 3 times y would be equal to 2 times 12, which would be 24. If I divide both sides by radical 3, I'll have 24 divided by radical 3. I can't really do that. So I'll have 24 radical 3 over 3, and this 3 goes into 24 8 times, so I'll just have 8 rad 3 is equal to y. 8 radical 3. Okay, if I do the tangent, I can go back and I can find the same sort of thing. So I see tangent is root 3 over 3. So then I know root 3 over 3 is equal to x over 12. So I know that 3x would be equal to 12 radical 3. So if I divide both sides by 3, x would be equal to 4 radical 3. So this would be 4 radical 3. That means if I wanted to find sine, if I want to check my work, sine of 30 degrees is 1/2, so let me go ahead and check that. 1/2 would be equal to 4 radical 3 over 8 radical 3. And the radical 3's will cancel, and 4 goes into 8 twice, so 1/2 is equal to 1/2. Perfect. Okay, so that information allowed me to write equations. The key in terms of what I did, so the reason I didn't solve this one first is because I had 2 variables. When I wrote out this equation for cosine, then I knew cosine of 30 degrees and I knew the side adjacent, and it allowed me to find the hypotenuse. Okay, so what you're always looking to do is write an equation that you can solve, like this one. In this case, there were 2 of them I would be able to solve. Tangent of 30 degrees is equal to x over 12. The reason I can solve it is as a single variable. So that's what you want to try to make sure you do. Okay, so in this case, it's going to be a little different because now I'm not working with a standard angle. So they're telling me that this is 53 degrees. Okay, and it's important you understand that when you start labeling your triangle, I'm going to write that out here because I didn't write very well. B is 53 degrees, and side A is 12. So what's important you remember is we always make C the hypotenuse, and if I'm talking about angle B, side B is opposite angle B. And you notice here's angle A, side A is opposite angle A. So when you label your triangles, the angles are labeled as capital letters, and they're opposite the side with the matching letter, and that would be notated with a lowercase letter. So if I want to go ahead and look and see what can I do with this, if I want to start finding parts, they've given me the side adjacent, so I could either find the side opposite by doing tangent. I know that tangent of 53 degrees would be the side opposite, that would be B, over the side adjacent, which is 12. Okay, so this would allow me then to find B. If I wanted to write an equation that would allow me to find C, I would go ahead and find probably cosine, because that would be adjacent over hypotenuse. So I know the cosine of 53 degrees would be equal to the side adjacent, which is 12, over the hypotenuse. Now, it's a little more complicated when I want to solve for a variable that's in the denominator, but not much. In 2 steps, I'm going to multiply both sides of the equation by this variable c. So c times the cosine of 53 degrees would be equal to 12. And then if I divide by cosine of 53 degrees, 12 divided by cosine of 53 degrees will give me c. Okay, so a couple of steps to solve for my variable. Over here it's very easy to just multiply both sides by 12. And then I would go ahead and pull out a calculator to finish up the problem. So here's my calculator, and I'm going to find tangent of 53 degrees. So 53 degrees tangent times 12 equals, B would be 15.92. So 15.92 is equal to B. Also, by the way, one thing I didn't talk about is if B is 53 degrees, then what's A? Well, A must be 47 degrees. So I could have started writing functions with, for instance, if I didn't want to have this guy being an inverse, I could have written a different equation using this other angle so that I didn't have my variable in the denominator, potentially. Okay, if I go back to my calculator to finish out this problem, so let's see, we found that B is 15.92. And then if I want to take 12 divided by 53 cosine, enter. My hypotenuse is 19.94. Okay, so 19.94. Right? We want to use a little logic here to just make sense. There is a ratio between the size of the angle and the size of the side. The bigger the angle, the bigger the side. The hypotenuse is opposite 90 degrees. It's always the longest side. So I see my smallest angle has the smallest side opposite. The next largest has the next largest side. And the hypotenuse is opposite 90 degrees, so this all makes sense. Okay, so I know that I found my hypotenuse, I found my other side, and I found my missing angle. So I have solved my triangle. When it asks you to solve a triangle, they're asking you to find all of the missing parts to the triangle. Okay, so go ahead and practice that. Do problems 17, 18, 23, and 24. Come on back and we'll finish this out. So when I take a look at this triangle, you see that they've given me an angle. So my theta is 76 degrees. They've supplied me the side adjacent, and I'm looking for the side opposite. So opposite and adjacent, I know would be tangent. So tangent of 76 degrees would be equal to my side opposite, which is x, over my side adjacent, which would be 2. So that means 2 times tangent of 76 degrees will be equal to x. I'll pull up my calculator again. 76 tangent times 2 equals, and I find that it's 8.02 miles in this case. 8.02 miles is equal to x. Okay, so the key is create the right triangle, check, observe which parts you need to work with. So I was given an angle and a side, and I had a target angle to find. Then I selected the appropriate trig function to let me find the parts that I needed. Okay, one more example like this. We have the idea that there's a parasailer who's attached to a boat with a rope that's 300 feet long, and we're interested in knowing how high the parasailer is. So when you start thinking about this, this is a right triangle. Over here I have my boat. Over here I have my parasailer up here in the sky, right? And what I want to know is I want to know this distance. How high is the parasailer above the height of the ocean, or in this case above the height of the boat? So the rope is 300 feet long, so this would be the rope. The rope is the hypotenuse. And the angle of elevation from the boat, this would be the angle of elevation, would be 48 degrees. So I have side opposite is what I'm looking for. Hypotenuse is what I have. So opposite and hypotenuse would be sine. So if I work with sine of 48 degrees would be equal to x over 300. Then I know that 300 times the sine of 48 degrees will be equal to this height. Going back to my calculator, oops, I'm going to find 48 degrees. I'm going to find the sine of that times 300 is 222 feet, 0.93, so almost 223 feet. Okay, so again, we're creating a scenario where we can draw out a picture that involves a right triangle, select the parts that we have, and then select the appropriate trig function for the parts that we wanted. I was looking for side opposite. I was supplied the hypotenuse. So opposite and hypotenuse would be sine.